Audio version of the blog post, Implementing an Effective and Repeatable Approach for Capturing Data Analytics System Requirements, by Gary Stafford, Senior Solutions Architect, Amazon Web Services. According to TechTarget, data analytics applications involve more than just analyzing data, particularly on advanced analytics projects. Much of the required work takes place upfront, in collecting, integrating, and preparing data and then developing, testing, and revising analytical models to ensure that they produce accurate results. In addition to data scientists and other data analysts, analytics teams often include data engineers, who create data pipelines and help prepare data sets for analysis. Introduction. Successful consultants, project managers, and product owners take a well-defined and systematic approach to achieve desired outcomes. They use frameworks, templates, and proven patterns to accomplish their goals, consistently successful engagements, project outcomes, and product and service launches. The goal of this platform-agnostic discovery process is to lead an organization, department, team, or customer through an effective, efficient, consistent, and repeatable approach for capturing data analytics workflows and system requirements. This process will result in a clear understanding of existing analytics workflows, current and desired future business and technical outcomes, and existing and anticipated future business and technical constraints. If applicable, the discovery process serves as a foundation for architecting new data analytics workflows. Starting with a set of business and technical constraints, the approach facilitates the development of new data analytics workflows to achieve desired business and technical outcomes. Outcomes and constraints determine the requirements. Analytics workflow stages. There are many patterns organizations use to delineate the stages of their analytics workflows. However, the granularity of the stages is not critical to this process as long as all major functionality is considered. This process utilizes 6 stages of a typical analytics workflow from left to right: generate, collect, prepare, store, analyze, and deliver. The discovery process starts by working backward and from the outside in. First, the process identifies current and desired future outcomes. Then, it identifies existing and anticipated future constraints. Next, it identifies the inputs and the outputs for the existing and re-architected workflows. Finally, the process identifies the current and re-architected analytics workflows: collect, prepare, store, and analyze, the steps required to get from data sources to deliverables. Specifically, the process identifies and documents the following. 1. Current business and technical outcomes. 2. Desired future business and technical outcomes. 3. Existing business and technical constraints. 4. Anticipated future business and technical constraints. 5. Inputs required to achieve desired outcomes. 6. Outputs needed to achieve desired outcomes. 7. Data producers and consumers. 8. Existing analytics tools, procedures, and people. 9. Measures of success for analytics workflows. Outcomes. Capture desired business and technical outcomes, also referred to as goals and objectives. For example, 1. Re-architect analytics workflows to modernize, reduce costs, increase speed, reduce complexity, or add new capabilities. 2. Move analytics workflows to the cloud. Use the 6 R's of cloud migration as a guide. The 6 R's are: rehost, replatform, repurchase, refactor, retain, or retire. 3. Migrate from another cloud or SaaS provider. 4. Shift away from proprietary platforms to an open-source analytics stack. 5. Migrate away from custom-built in-house analytics tools. 6. Incorporate data ops automation into analytics workflows. 7. Integrated hybrid, on-premise, multi-cloud, and SaaS-based analytics architectures. 8. Develop new greenfield analytics workflows, products, and services. 9. Standardize disparate analytics workflows. 10. Develop machine learning models from the data. 11. Provide key stakeholders with real-time business KPI dashboards. Constraints. Identify the existing and potential future business and technical constraints that impact analytics workflows. For example, 1. Budget and cost allocation requirements. 2. Timelines. 3. People, including specific skill gaps. 4. Internal and external regulatory, data governance, and data lineage requirements. 5. SLAs and KPIs, the measures of workflow effectiveness. 6. Current vendor, partner, cloud provider, and SaaS relationships. 7. Licensing and contractual obligations. 8. Identify any aspects of current analytics workflows that must be maintained. Inputs. Capture sources of data that are required to produce the outputs. For example, 1. Batch sources such as databases and data feeds. 2. Streaming sources such as IoT device telemetry, operational metrics, logs, clickstreams, and gaming stats. 3. Database engines, including relational, key value, document, in-memory, graph, time series, and wide column. 4. Data warehouses. 5. Data feeds, such as flat files from legacy or third-party systems. 6. API endpoints. 7. Public and licensed datasets. Use the 5 V's of data to dive deep into each data source. They are volume, velocity, variety, veracity, and value. Capture existing and anticipated data access and usage patterns. Outputs. Identify the deliverables required to meet the desired outcomes. For example, 1. Further analysis. 2. Business intelligence, visualizations, and dashboards. 3. Machine learning and artificial intelligence. 4. Data exports, such as Microsoft Excel or CSV format flat files. 5. Hosted datasets for external or internal consumption. 6. Expose data via APIs. Analytics workflows. Capture analytics workflows using the 4 stages: collect, prepare, store, and analyze, as a way to organize this part of the process. 1. High and low-level architecture, process flows, patterns, and external dependencies. 2. Analytics tools, including hardware, commercial, custom, and open-source software, libraries, modules, source code. 3. Data ops, continuous integration, continuous delivery, DevOps, and infrastructure as code automation. 4. Cross-cutting concerns such as security, observability, and cost allocation. 5. People, including managed service providers, roles and required skills. 6. Partners, including consultants, vendors, SaaS providers. 7. Overall effectiveness and customer satisfaction with existing analytics workflows. 8. Deficiencies with current workflows. Use checklists for each stage to ensure all potential features, functions, and capabilities of typical analytics workflows are considered and captured. For example, review a checklist of all possible ways data is typically collected to ensure nothing is missed. Measures of success. Identify how success is measured with respect to the analytics workflows, and by whom. For example, 1. Key performance indicators, KPIs. 2. Service level agreements, SLAs. 3. Customer satisfaction score, CSAT. 4. Net promoter score, NPS. 5. Explanation of how measurements are determined, calculated, and weighted. And lastly, data producers and consumers. Capture all the data producers and data consumers. Results. The result of the data analytics discovery process is a clear and concise document that captures all elements described herein. Additionally, the document contains any customer-supplied artifacts, such as architectural and process flow diagrams. The document is thoroughly reviewed for accuracy and completeness by the customer. This document serves as a record of current data analytics workflows and a basis for architecting new workflows. This blog represents my own viewpoints and not of my employer, Amazon Web Services.